So good day everyone. My name is Girly Oliveros Lara and my topic is all about the chapter 6 of Advanced Management Information System. The basis of business intelligence management under databases and information management. After completing this chapter, here are the course intended learning outcomes. So the student should be able to answer the following questions. Number one, what are the problems of managing data resources in a traditional file environment and how they solve by a database management system? Number two, what are the major capabilities of database management systems or DBMS and why is a relational DBMS so powerful? Number three, what are some important principles of database design? Number four, what are the principal tools and technologies for accessing information from databases to improve business performance and decision making? Number five, why are information policy, data administration, and data quality assurance essential for managing the firm's data resource? An effective information system provides users with accurate, timely, and relevant information. Accurate information is free of errors. Information is timely when it is available to decision makers when it is needed. Information is relevant when it is useful and appropriate for the types of work and decisions that requires it. Now, many businesses don't have timely, accurate, or relevant information because the data in their information systems have been poorly organized and maintained. That's why data management is so essential. A computer system organizes data in hierarchy that starts with bits and bytes and progresses to fields, records, files, and databases. Now, as you can see here, a bit represents the smallest unit of data a computer can handle, followed by a byte. A group of bits called a byte represents a single character which can be a letter, a number, or another symbol. A grouping of characters into a word, a group of words, or a complete number such as person's name or age is called a field. A group of related fields such as student's name, the course taken, the date, and the grade comprises a record, and a group of records of the same type is called a file. A group of related files makes up a database. The student course file illustrated here could be grouped with files on students' personal histories and financial backgrounds to create a student database. Now, a record describes an entity. An entity is a person, place, thing, or event on which we store and maintain information. Each characteristic or quality describing a particular entity is called an attribute. For example, student ID, course, date, and grade are attributes of the entity course. The specific values that these attributes can have been found in the fields of the record describing the entity course. In most organizations, systems tended to grow independently without a company-wide plan. Accounting, finance, manufacturing, human resources, and sales marketing all developed their own systems and data files. Each application, of course, required its own files and its own computer program to operate. For example, the human resources functional area might have a personal master file, a payroll file, a medical insurance file, a pension file, a mailing list file, and so forth until tens, perhaps hundreds, of their files and programs existed. In the company as a whole, this process led to multiple master files created, maintained, and operated by separate divisions or departments. So as this process goes on for 5 to 10 years or 5 or 10 years, the organization is saddled with hundreds of programs and applications that are very difficult to maintain and manage. The resulting problems are data redundancy and inconsistency, program data dependence, inflexibility, poor data security and an inability to share data among applications. Data redundancy and inconsistency. Data redundancy is the presence of identical data in multiple data files, resulting in the storage of the same data in multiple locations. Now, where the same attribute may have different values, data redundancy wastes storage resources leads to data inconsistency. For example, in instances of the entity cores, the date may be updated in some systems but not in others. The same attribute, like student ID, it may also have different names in different systems throughout the organization. Some systems might use a student ID, and others might use ID, for example. Program data dependence. Program data dependence is a relationship between the data that are kept in files and particular programs needed to update and maintain those files, making it necessary for data changes to occur when programs are changed. Every conventional computer program is required to specify the location and type of data it uses. Any modification to a software program in a conventional file environment could need a change in the data that program accesses. A 5-digit zip code could be changed to a 9-digit zip code with one program. Other programs that require the 5-digit zip code would no longer function properly if the original data file were altered from 5 to 9 digits. So, in this problem, millions of dollars may be required to properly implement such modifications. To continue, lack of flexibility is also a controversy in traditional file environment. Ad hoc queries need information that is somewhere in the system but may be too expensive to retrieve. Several programmers might have to work for weeks to put together the required data items in a new file. Next is poor security. So here, management may have no way of knowing who is accessing or even making changes to the organization's data. And last is the data availability and sharing issues. It is practically hard to communicate or access information quickly because bits of information in various files and areas of the organization cannot be coupled to one another. Many of the issues with conventional file organizing are solved by database technology. So a more precise definition of database is a collection of data organized to serve many applications efficiently by centralizing the data and controlling redundant data. It can also support multiple applications. So for example, instead of a corporation storing employee data in separate information systems and separate files for personnel, payroll, and benefits, the corporation could create a single common human resource database. Database Management Systems or DBMS. Database Management System is a software that enables an organization to consolidate data, manage it effectively, and give applications access to the data contained in the system. It is also serves as a link between applications and the actual data files. Now, essentially, a database management system is a software that permits an organization to centralize and manage data effectively. And also, it provides access to the stored data by application programs. Now, when an application software requests a data item, such as CrossPay, the database management system locates the requested item in the database and displays it to the application program. When using conventional data files, the programmer would have to tell the computer where each data element was located after describing its size and the format. By separating the logical and physical views of the data, The DBMS frees the programmer or end user from having to comprehend where and how the data are actually kept. The physical view demonstrates how data are actually arranged and structured on physical storage media, as opposed to the logical view, which depicts data as they would be seen by end users or business specialists. The data management system acts as an interface between applications, programs, and the physical data files. So using the traditional data files, the programmer would have to specify the size and format of each data element used in the program and then tell the computer where they get or where they were located. A data management system is a set of programs that is used to store, retrieve, and manipulate the data in convenient and most efficient way. So as you can see here, a single human resources database provides many different views of data, depending on the information requirements of the user. So, illustrated are two possible views, one of the interest to a benefits specialist and one of the interest to a member of the company's payroll department. So, the goal of data management system is to hide underlying complexities of data management from users and provide easy interface to them. The data management software makes the physical database available for different use by required by the users. How a DBMS addresses issues of the traditional file environment. So, DBMS reduces data redundancy and inconsistency by minimizing isolated files in which the same data are repeated. DBMS also may not be enable the organization to eliminate data redundancy entirely, but it can help control redundancy. Even if the organization maintains some redundant data, using a DBMS eliminates data inconsistency because the DBMS can help the organization ensure that every occurrence of redundant data has the same values. Relational DBMS. Contemporary DBMS use different database models to keep track of entities, attributes, and relationships. Relational databases represent data as two-dimensional tables called relations. Tables may be referred to as files. Each table contains data on an entity and its attributes. Microsoft Access is a relational DBMS for desktop systems, whereas DB2, Oracle Database, and Microsoft SQL or Structured Query Language Server are relational DBMS for large mainframes and mid-range computers. Now, the most popular type of DBMS today for PCs as well as for larger computers and mainframes is the relational DBMS. Now, let's examine this table on how a relational database arranges information about vendors and components. The entity supplier and the entity part each have their own tables in this database. Now, each table is made up of grid of informational columns and rows. Each field represents an attribute for that entity, and each unique piece of data for each entity is saved as separate field. A relational database's fields can also be referred to as columns. Each field in the supplier table that is stored for the entity supplier indicates an attribute, including the supplier identity number, name, street, city, state, and zip code. Now, a row in the table refers to the real data about specific supplier that is contained within, informally known as records or, in more technical terminology, tuples. The data for the part entity are in a different table. Each record in the supplier database is uniquely identified by its supplier number column so that it may be queried, changed, or sorted. It's known as a critical field. In a relational database, each table contains a single field that serves as its primary key. This main key column serves as the only means by which all the data in every table row may be uniquely identified. Now, the primary key for the supplier table is supplier number, and the primary key for the part table is part number. The supplier number is visible in both the supplier and part tables. As you can see, supplier number serves as the main key in the supplier table. It is referred to be a foreign key when the field supplier number occurs in the part table because it serves as a field for looking up information about the supplier of a certain part. Capabilities of database management systems. A DBMS includes capabilities and tools for organizing, managing, and accessing the data in the database. So the most important are its data definition language, data dictionary, and data manipulation language. DBMS have a data definition capability to specify the structure of the content of the database. It would be used to create database tables and to define the characteristics of the fields in each table. This information about database would be documented in a data dictionary. Now, data dictionary is an automated or manual file that stores definitions of data elements and their characteristics. And the data manipulation language is used to add, change, delete, and retrieve the data in the database. Users can make queries using Microsoft Access by specifying the tables, fields, and results they want, then choosing the rows from the database that adhere to a specific criteria. Now, these subsequent actions are converted into SQL commands, or what we call the structured query language. In this figure, it shows that how SQL or structured query language choose suppliers and parts would be created using the Microsoft Query Building tools. So as you can see here, Microsoft Access has a rudimentary data dictionary capability that displays information about the size, format, and the characteristics of each field in the database. So displayed here is the information maintained in the supplier table. The small key icon to the left of the supplier number indicates that it is a key field. To create a database, we must understand the relationships among the data, the type of data that will be maintained in the database, how the data will be used, and how the organization will need to change to manage data from a company-wide perspective. Now, the database requires both conceptual and a physical design. The conceptual or logical design of a database is an abstract model of the database from a business perspective, whereas the physical design shows how the database is actually arranged on a direct access storage devices. Normalization and entity relationship diagrams. The process of decomposing unsatisfactory or bad relations by breaking up their attributes into smaller relations is called normalization. While designing a database out of an entity relationship model, the main problem existing in that raw database is called redundancy. Redundancy is storing the same data item in more one place. A redundancy creates several problems like extra storage space, entering same data, deleting data from more than one place, modifying data, and sometimes, for some instances, anomaly may occur. Now, to solve this problem, the raw database needs to be normalized. This is a step-by-step process of removing different kinds of redundancy and anomaly at each step. Now let's take a look at these figures to see the differences between unnormalized and normalized tables relation for order. So as stated, an unnormalized relation contains repeating groups. So there can be many parts and suppliers for each order. Um, and only one-to-one correspondence between order number and order date. While in normalized tables created from order, as stated also, after normalization, the original relation order has been broken down into four smaller relations. The relation order is left with only two attributes, and the relation line item has a combined or concatenated key consisting of order number and part number. Let's talk about entity relationship or ER diagram. ER diagram is defined as a specialized graphical tool that demonstrates the interrelationships among various entities of a database. So basically, it is used to represent the overall logical structure of a database. And it focuses high-level database design and hides low-level details of database representation. So therefore, it can be used to communicate with users of the system while collecting information. Data warehouse and data marts. Data warehouse is a database that houses both recent and old data that might be useful to decision makers across the whole business. So the example of this are those data originated in many core operational transaction systems, such as systems for sales, customer accounts, manufacturing, and sometimes it may include data from website transactions. Now, as the company often build enterprise-wide data warehouses, where a central data warehouse serves the entire organization, they create smaller, decentralized warehouses called data mart or data marts. Data mart is a subset of a data or data warehouse in which a summarized or highly focused portion of the organization's data is placed in a separate database for a specific population of users. So, for example, a company might develop marketing and sales data marts to deal with customer information. Now, Hadoop is capable of processing huge amounts of any type of data. And on the other hand, Hadoop is defined as widely used in the big data processing and analysis and has become a popular tool for organizations that deal with massive amounts of data. It provides effective way to store, process, and analyze large data sets making it easier for businesses to extract valuable insights and information from their data. So the best example of this Hadoop is the use of Facebook to manage and analyze their massive amounts of data. Facebook uses Hadoop to process and analyze over 300 petabytes of data every day, including user interactions, posts, messages, and more. Now, how can we differentiate database from data warehouse? There are a number of fundamental differences which separate a data warehouse from database. The biggest difference between them is that most databases place an emphasis on a single application, and this application will generally be one that is based on transaction. If the data is analyzed, it will be done within a single domain. In contrast, data warehouses deals with multiple domains simultaneously. So in this figure, the data warehouse extracts current and historical data from multiple operational systems inside the organization. So these data are combined with data from external sources and reorganized into a central database designed for management reporting and analysis. So the information directory provides users with information about the data available in the warehouse. Online Analytical Processing or OLAP. OLAP supports multidimensional data analysis, enabling users to view the same data in different ways using multiple dimensions. So essentially, each aspect of information such as product, pricing, cost, region, or time period represents a different dimension. So the goal of OLAP or multidimensional data is to support analysis in a simple and faster way by executives, managers, and business professionals. These people are not interested in the overall architecture. For example, your company is supposed to sell five different products like laptops, computers, TVs, cameras, and mobiles in each of your regions, in East, West, North, and Central regions. Now, if you wanted to know or to ask a question such as how many computers were sold in the last week, you could easily find the answer by using the sales database. But if you wanted to know how many computers were sold in each of your sales regions and compare actual results with projected sales, then the querying becomes complicated. So, in this situation, OLAP or Online Analytical Processing is very essential to use. Now, let's proceed to data mining. Data mining provides insights into corporate data that cannot be obtained with OLAP by finding hidden patterns and relationships in large databases and inferring rules from them to predict future behavior. So in short, um, data mining is the semi-automatic process of extracting and identifying patterns from stored data. Functions of data mining. The types of information obtainable from data mining includes associations, sequences, classifications, clusters, and forecasts. Now let's define association. Association is one of the best-known data mining techniques. In association, a pattern is discovered based on a relationship between items in the same transaction. That is the reason why association technique is also known as relation technique. The association technique is used in the market or market basket analysis to identify a set of products that customers frequently purchase together. So for example, books that tends to be bought together. If a customer buys a book, an online bookstore may suggest other associated books. If a person buys a camera, the system may suggest accessories that tend to be bought along with cameras. Now in sequences, events are linked over time. We might find, for example, that if a house is purchased, a new refrigerator will be purchased within 2 weeks, 65% of the time, and an oven will be bought within 1 month of the home purchased 45% of the time. Now, in classification recognizes patterns that describe the group to which an item belongs by examining existing items that have been classified and by inferring a set of rules. So, for example, businesses such as credit card or telephone companies worry about the loss of steady customers. Classification helps discover the characteristics of customers who are likely to leave and can provide a model to help managers predict who those customers are so that the managers can devise special campaigns to retain such customers. Clustering. Clustering works in a manner similar to classification when no groups have yet been defined. A data mining tool can discover different groupings within the data, such as finding affinity groups for bank cards or partitioning a database into groups of customers based on demographics and types of personal investments. Although this application involves prediction, forecasting uses predictions in a different way. It uses a series of existing values to forecast what other values will be. So, for example, forecasting might find patterns in data to help managers estimate the future value of continuous variables, such as sales figures. Text mining. Text mining are the tools that are able to extract key elements from large unstructured data sets, discover patterns and relationships, and summarize the information. Businesses might turn to text mining to analyze transcript of calls to customers or customer service centers to identify major service and repair issues. Now, in web mining, the web is another rich source of valuable information, some of which can now be mined for patterns, trends, and insights into customer behavior. So essentially, the discovery and analysis of useful patterns and information from the World Wide Web is simply called web mining. So, web mining is the application of data or data mining technique to extract knowledge from web data, including web documents, hyperlink between documents, and usage of logs of websites. Any company, regardless of the size, needs an information policy. Data from your company are a valuable resource and you don't want anyone to use them any way they like. Rules must be established regarding who can access the data, how it should be maintained, and how it should be changed. Now, information policy is a specific organization's rules for sharing, disseminating, acquiring, standardizing, classifying, and inventorying information. It lays out specific procedures and accountabilities, identifying which users and organizational units can share information, where information can be distributed, and who is responsible for updating and maintaining the information. Now, the owners of management of a small business will establish and carry out the information policy. It is common in large organizations to need a formal data administration or administration role to manage and plan for information as a corporate resource. The exact policies and procedures that allows data to manage a resource for an organization are the responsibility of a data or a data administration. These duties includes creating information policy, organizing data, supervising the creation of logical databases and dictionaries, and keeping an eye on how information systems or systems professionals and end user groups use data. Many of these activities might be referred to as data governance. Data governance is a concept supported by IBM that focuses on fostering privacy, security, data quality, and compliance with governmental standards, while also controlling the policies and procedures for managing the availability, usability, integrity, and security of the data used in an enterprise. The firm will have the information it needs if the database and information policy are well designed. To make sure that the information in the organizational databases is accurate and continues to be dependable, extra measures must be implemented. Now, in ensuring data quality audit and data cleansing is very important. Organizations must recognize and fix incorrect data before implementing a new database and develop improved procedures for amending data once the database is operational. Data quality audit is frequently the first step in the analysis of data quality. It is a structured survey of the accuracy and level of completeness of the data in an information system. It is also performed by surveying entire data files, surveying samples from data files, and surveying end users for their perceptions of data quality. Data cleansing. Data cleansing, also called as data scrubbing, consists of activities for detecting and correcting data in a database that are incorrect, incomplete, improperly formatted, or redundant. Data cleansing not only corrects errors but also enforces consistency among different sets of data that is originated in separate information systems. So I think that's it for my presentation. Thank you so much everyone for listening, and I hope you learned something from this topic. Thank you once again.